So good morning, and again welcome to this lecture of electronics. Myself, Dr. N.D. Meshram, Head and Associate Professor, Department of Electronics, Sri Mathura Das Mohta College of Science. And today I am expecting to complete another topic of say another topic which is actually full wave rectifier, right? So yesterday we have studied half wave rectifier, and today we need to complete full wave rectifier. So let us start what we have started or what we have studied in the last lecture first. So we have studied the RTM Nagpur University syllabus of semester 3 paper 1, in which we have started with the rectifier portion. And I guess I have taught you these were the three rectifiers that we have to study in this lecture. And I guess we have studied this definition. Rectifier is an electrical circuit that converts alternating current, which is periodically reverses directions, to direct current. Direct current, DC, which is in only one direction, and that particular process is called as rectification, right? So rectification means to have a smooth or a constant output voltage, whether it is plus 5 volt or whether it is minus 5 volt. It is materialistic, but it will remain plus 5. Whereas in alternating current, it changes with respect to time. So I will show you. Yeah. So this is the graph. Sorry, this is the wave that I am expecting. First wave. I guess my presentation is visible and my cursor is also visible to you. So this is that AC wave which we are trying to make it DC like this. So pure DC is like this after we apply it to a filter. Before we apply it to a filter, I have yesterday taught you this is the 230 volt AC 50 hertz frequency which is coming at our home, right? And this has been given to the transformer. Now this is actually the step down transformer, which implies that it is actually stepping down the AC voltage or current which is given to this. So 230 volt AC is being converted into 12 volt 12 volt AC, or say 5 volt AC, depending on the transformer, right? So it is decreasing the AC voltage to a lower AC. So the transformer is not a rectifier, but transformer converts a higher AC into lower AC and vice versa. So remember this, it is vice versa, means we are having both types of transformers. We are having step down transformer as well as we are having step up transformer, right? So we all are, say, we are having this step up and step down transformer in that case. So I have yesterday taught you that, and then we are using this rectifier circuit. So these rectifier circuits we are studying today: half wave, full wave, and bridge rectifiers. These are three types of rectifiers which we use. And after this rectifier, the output of this rectifiers are actually like this, which we call it as the pulsating DC. That's it. It is not a pure DC. If you are able to see, they are waves. So half of the wave are being say rectified. Now to get a pure DC, we require some filter circuits like this. So we use these filters, which are capacitor, inductor, and say both. So we can use those filter circuits, and we will be studying this in this chapter itself. And after this filter circuit, we will be getting a smooth voltage like this. So we will be having a plus 5 volt or minus 5 volt accordingly as per our requirement. So this is the rectifier circuit that we are expecting to study in this unit. This is the filter, and after filter we require some voltage regulator to regulate the voltage exactly at this level. What happens, there are fluctuations in the AC voltage, that is 230 volt AC. So it does not remain 230 volt. It varies from say 170 or 180 volts to 240 to 60 volts, and it keeps on fluctuating. So it is not constant, right? So because of this change in the AC voltage, there are change in the output voltage also. So if we are using the standard 230 volt and we are expecting 12 volt over here, and this voltage is increased to say 260 volt, so automatically the output voltage of this will also increase say to 13 or 14 volt AC, right? So this fluctuation affects here. So to make this as constant, whether there is changes in the say mains or not, it should remain constant. We require this voltage regulator circuit, which is going to regulate the voltage at a certain potential or certain voltage. Say if it is we require it say plus 12 volt, then it should remain at 12 volt. It should not fluctuate plus 13, 14, or say minus 11 or 10. It should not vary like this, but it should remain 12 volt. So for that we require this voltage regulator, and here we are expecting the DC regulated output voltage. So this is the block diagram of a power supply. Types of rectifiers, we have studied this: half wave, full wave, and bridge rectifier. And we have yesterday started with half wave rectifier. We have almost completed. In half wave rectification, either the positive or negative half of the AC wave is passed, while the other half is blocked. So remember this: only half of the wave, half of the full sine wave is being rectified, and the other half is blocked. So because of this, what happens? Because of this, it becomes inefficient because maximum power is not being transferred, right? So we are not using the full power. So this is the basic circuit diagram of the half wave rectifier, in which we are employing only one diode, and this diode is connected. So it can be a simple diode also. Here it is written crystal diode, but a simple diode can also work. So we are having this as the primary of winding of the coil. The AC is applied to the primary coil of the primary winding of the coil, that is P1 and P2, and the output is say output we get across the secondary. So this is S1 and S2, which are written A and B over here. So S1 and S2 are the secondary. The S1 is connected to the anode of the diode B, and the cathode is connected to S2, that is point B, through the load resistance RL. That is what we are expected to tell you while you are explaining the construction. So the anode of the diode D is connected to S1, and the cathode is connected to the S2 through the load resistance RL. Okay. Now the output is taken across this load resistance. This load resistance is the device or the resistance of that device which we need to apply this voltage, right? So that we are using it as a resistance. So we call it as the load resistance, right? A simple resistor. So this is the basic circuit diagram of half wave rectifier. And what happens to the circuit? So as soon as the first positive half comes across this, so we will divide this into two halves. The first half, sorry, so the first half is over there. So as soon as the first positive half cycle of the diode, first half cycle AC input cycle comes across this diode, so what happens? The anode of the diode becomes forward bias. So this is positive and the cathode is negative, right? So as soon as this anode is positive and the cathode is negative, so the diode is forward bias, right? And as soon as this diode is forward bias, the diode will conduct. The diode will conduct. The flow of electrons will be in the opposite direction, like this, and the direction of flow of current will be from, say, anode to cathode. So the current flows from anode to cathode in the positive half cycle. Why? Because this diode becomes, say, forward bias. The diode is in forward bias. The arrows which are shown over here, they are showing the direction or the flow of the electrons. So the current always flows opposite to the direction of flow of electrons, right? So in the positive half cycle, the diode is forward bias and diode conducts, and therefore the positive half cycle is appears across this load resistance, and this is the output wave. So we'll have this half of the wave being rectified. Now during the negative half cycle, that is the lower half of this, what happens? This anode is negative and this cathode becomes positive, which implies that this diode is reverse bias. And if this diode is reverse biased, then what happens? The diode will not conduct. And during this situation, when the diode does not conduct, the half wave, the negative half cycle, is blocked over here. So you are able to see in this animation that the negative half is not appearing across this, right? And after that, it again starts the positive half, and the positive half is appearing across it. So only positive half, or say in that case, if you reverse the polarity of this diode and if you connect this diode on in this portion, then the negative half will be rectified, the positive half will be not rectified. So the meaning is only half of the wave is being rectified, and due to that, that is why this is called as a half wave rectifier circuit, right? So only half of the wave is being rectified. So this is the basic circuit diagram of the half wave rectification. The output DC voltage of a half wave rectifier can be calculated with the following two ideal equations. This is VRMS, root mean square voltage, is equal to V peak to peak divided by 2. So this is the DC voltage, that is what we are expecting out of the rectifier. So this is across approximately equal to V peak to peak divided by 2, right? And that can be written as VDC is equal to, so V peak by pi. So these are the two formulas. where we can have the DC voltage. What would be the DC voltage of this? So for a single phase AC, if a transformer is a center tap, okay. Now we can start with the full wave rectification. Have you understood the half wave rectifier? So in full wave, what happens in a single phase AC, if the transformer is center tap transformer, then two diodes back to back, that is anode to anode or cathode to cathode, can form a full wave rectifier. So now we are having a full wave rectifier as shown in this diagram. As shown in this diagram, yeah, here we are employed only one diode. So if you use two diodes over here, one on this side and the other one on this side, and then we connect a center tap transformer. Now I will show you what is a center tap transformer. So this is the center tap transformer, right? So where we are having a central terminal. So what I have told you, that we are having two diodes D1 and D2, which are connected to S1 and S2, and S is the center tapping, right? So S divides the voltage into two parts. If it is 12, 0, 12, which implies that from this point to S1 will be having 12, and from this S to S2 will again have 12, right? So this is called as the center tapping, S over here. So we have connected two diodes D1 and D2 like this, and the cathode of both of them are being connected, and the center connected to this point, and this point is again given to the center tapping, that is S, through the load resistance RL, right? So we are connecting the both the cathodes together, and the some connection can be connected to the center tapping through the load resistance RL. Now how it works? Again, the same situation is there. We have applied an AC voltage, and this is a center trap transformer where we are having three terminals, S1, S, and S2 of the say transformer, right? So during the positive half cycle, what happens? This S1 will be positive and S2 will be negative. Okay, so during this positive half cycle, S1 will be positive and S2 will be negative with respect to S. Now we are considering with respect to S. So as S1 is positive, this diode D1, anode of diode D1 will be positive and cathode will be negative, right? So as soon as this becomes positive, the diode D1 will be forward bias, whereas the diode D2 will be reverse bias. So the current will flow from S1 diode D1 and this summing point over here. And from this summing point, we'll be having through load resistance, and then it is connected to center tapping S, and then it is again fed back to S1. So thus the circuit is complete from S1, D1, RL, S, and again back to S1. So all the circuit completes and half of the wave is being rectified. Secondly, during the negative half cycle, what happens? This S2 will be positive and S1 will be negative. So diode D1 will not conduct it since it is reverse bias, and diode D2 now it is forward bias since S2 is positive, right? So D2 is forward bias, so the current will start flowing from S2 D2 to say the RL, and RL to again S, right? And S to again S2. So both the waves, that is the positive wave as well as the positive half as well as the negative half, has been rectified. So if you are able to see this animation, okay. So here what happens? Whole of the wave has been rectified. So that is why it is we call it as a full wave rectifier. So this half is being rectified by D1, and the negative half is being rectified by D2, and ultimately across the load resistance RL, we will be having the full wave like this. So will be having a pulsating DC like this, and full of the wave is being rectified. So this is the full wave rectification. In a circuit with a non-center tap transformer, four diodes are required instead of one needed for half wave rectification. So this is the circuit diagram for full wave rectifier, and for the another half wave rectifier will be looking at in the another class, right? So this is the formula for the root mean square of the full wave rectifier. Here you are able to see it is twice of Vp by pi because of full wave is being rectified. Okay, and Vrms is equal to Vp by under root of 2. So this is how the full wave is being rectified. Okay, and this is a full wave bridge rectifier. So this is what we will be continuing in the next lecture. I guess this is understood. So this is half wave rectifier, and this is how it works during the first positive half cycle diode. This works, and during the negative half cycle, the another diode will work in this, say, in the full wave rectification. So in this, we will be requiring a center tap transformer where we are having three terminals in the transformer, right? So we are employing two diodes, D1 and D2 accordingly. Okay, I guess you have understood this full wave rectifier circuit. And if you have any questions, you can ask. Do you have any questions? So thank you very much for joining. And I guess you have understood what is a half wave rectifier and a full wave rectifier circuit. In the next lecture, we'll be continuing with the full wave bridge rectifier circuit, right? But then, thank you very much. Stay tuned to my YouTube channel. Go through my YouTube channel. I will be uploading more videos on those electronics. And please like, share, and subscribe my videos. Thank you very much for joining. Have a nice day. Stay home, stay safe, take care. Have a nice day. Bye. Good day. See you in the next.